Does anybody else feel a little bit weird about the moderator? Nightbot is really like getting mad at this stuff. I didn't even think, I thought I disabled Nightbot. I really didn't think I did. Well, because it like, who knows? Spam protection, enabled, disable links, because that's just like ridiculous. I thought I disabled this. I guess I have too many things. Too many moderators, too much, anyway. Welcome to, oh, let's turn that chill beats down so you can actually hear me talk. Welcome to Rest Week, day 25. By that I mean 4. It feels like 25 though, considering the fact that we really haven't gotten anything done. Why can't we turn the volume up 112%? That would be amazing. Yeah, so we're hoping for no lags today. No lags, no frame drops. That's our goal for today. We've cut our frame rate in half. We've cut our bit rate in half. We are literally sending the minimal amount of data possible over the wire. That is like the goal for today, is to produce, not Rust by example, we need Rust the book. The Rust book. Anyway. Yeah, like our goal for today, besides doing programming, is like our goal for today, besides doing programming, is now the placement of the camera is going to drive me crazy. We just want to have good quality video, right? Like, we don't want this video to lag. I don't want buffering. Like, we don't want to use up all of my internet because we know my internet's shoddy. Just want it to work. For consistency, right? Like, all kinds of consistency. I don't know if, like, zooming in is what I want. something out of this. So now we can see the picture of my pretty dogs. It's not straight. Now it's straighter. It zoomed in. It's a little dark. Now it's blurry. Now it's not blurry. Now it's super crisp. Should we zoom in? Oh, now you get like just my face. Isn't that what you've always wanted, Mr. Max? As much of my face as possible. A minimum amount of background. I feel this feels backwards. We're good. So good. So good. So we should be on programming the guessing game. So let's do... Should we do a side-by-side? See if we can get this working pretty consistently. We can CD code Rust week. Cool. Well, we're starting a new program. We can always start a new branch. This is gonna be really fun when if and when. I haven't pushed this to GitHub yet, cause like I don't feel like there's been anything like worthwhile to push to GitHub. And so if there's nothing worthwhile to push to GitHub, why push it to GitHub? So we haven't done that. Twitcher. Cool. I feel weird that those are there. But hey. Whatever. Whatever. Let's go forward and do some rusts. Should we do some rusties? Seriously, I need the emote of the Rusty's car. That's what I need. I need the Rusty's car, the trusty Rusties. From Cars. Okay. Let's jump into Rust by working through a hands-on project together. This chapter introduces you to a few common Rust concepts by showing you how to use them in a real program. You'll learn about let, match, methods, associated functions, using external crates, and more! Exclamation point. I apologize in advance for every time I compare this to Go. I apologize in advance. Do you apologize in advance, Lou? Do you want Max's Chewy? Lulu, look right here. Good girl. You say hi. You say hi for the Chewy. Lulu. Good girl. There you go. Our pups got haircuts today. They're looking sharp. You can check them out on the Instagram if you really want a good look at them. They each have their own, or you can just look on mine, I'm pretty sure. I've put the dogs up by now. Beautiful dogs on the Instagram. Feel free to take a follow. So, we'll implement a class or beginner programming problem, a guessing game. Here's how it works. The program will generate a random integer between 1 to 100. Then we'll prompt the player to enter a guess. Oh, I love when they teach you to do like CLI-based games. We do those in college all the time. It's like, win. I mean, I don't know. I don't do a whole lot of stuff. Like, practically, I don't feel like I've ever done a lot of things where I prompt the user to enter, like, those are always on setup things, and they usually give you an option, like, when you set up, like, your Golang CLI, or, like, I don't know, I don't, maybe that was a thing once, to actually play games, like, via the terminal, but, like, I only ever do configs for the terminal, and they only ever prompt me when I'm doing, like, oh my goodness, like the Google Cloud setup they prompt me. Anyway. Cool. So we're going to be playing a game through the terminal. After a guess is entered, a program will indicate whether the guess is too high or too low. If the guess is correct, the game will print a congratulatory message and exit. We should make this like the same size as that text. That's pretty close. And resize that. Cool. So we'll do cargo new, because cargo new makes the new folder inside. And we'll do guessing game. And since this is like well-known code, we'll do example. Because I feel like if I don't put example on there, I am proprieting somebody else's stuff. And we don't want to propriet. Is that a word? Take proprietorship. Become a proprietor of? That would appropriate? Is that the word? When you become appropriate? Oh my gosh, I'm gonna just yawn all day. CD guessing game. CDQ. Cool, we have a source. First command cargo new takes the name of the project, which for us was guessing game example. I say us, just me. Unless there's more than one of us now. How you doing, guys? Is there more than one of us now? Will there be more than one of us in the future? Is there more than one of us forever? I feel like I get more fans when I share this on Slack. Should we, I'm trying to not abuse my Slack privileges and, like, post me going live on Slack. I should, or, like, Discord, or, like, I mean, if it was mine, but, like, community ones, I feel like that's an abuse of power, especially when I'm an admin for them. Who knows? I'm yawning. Okay. Look at the generated cargo file. I feel like that was command. Oh, look. Package guessing game 0.1.0. Your name with a GitHub example. See more keys. Oh my gosh. It is like identical. If the author information at cargo obtained in your environment is not correct, fix that in the file and save it again. Yeah, it looks great. Let's go to our main file. Still says hello world. That's great. Should we do a cargo run? And it should still print hello world after said it compiled. Building, come on little tickers. Oh, it works. Yay! The generated commands work. Guys, one day I'll actually be able to program in Rust, and this will all be trivial. Every single one of these videos of me struggling and complaining about how Rust is not as cool as Golang/Go will be trivial, because I will know what I'm doing, and I will be a Rust expert, a Rustpert. They call themselves rustaceans like the crabs, but if I'm a go-evangelist, then I can be a rustbird. That is spelled go-evangelist / rustpert. That a thing? It is now. It wasn't a command, but it's a thing because I wrote it. We should be on the processing the game part. Processing the game. I just read chapter 3, common programming concepts is common programming misconceptions. I don't know why I want there to be misconceptions. I don't know why I'm so yawny. I mean, I do know why I'm so yawny. It's because I'm talking more than I'm breathing, because I talk to myself when I'm uncomfortable. And right now, that silence is making me uncomfortable. Which means time to turn up the music. Time to turn up the music! Okay. Now I am less uncomfortable. Okay. The first part of the guessing game program will ask the user for input, process that input, and check that the input is in the expected form. To start, we'll allow players to input a guess. Enter the code enlisting 2-1 into your source main. VIM source main. Okay. Okay. Well, I mean, should we copy and paste, or should we, like... Well, let's copy and paste, and what we'll do is, like, something I'm really good at is taking notes in line. I learned that taking notes in my textbook as a fitness. Because when you study physics, your notes will always be pointless. Just 90% of the stuff you get in physics. Print line. Guess the number. Please input your guess. And remember, exclamation point means macro. I'm going to add that. Remember, exclamation point means macro. I wonder, like, in CS terms, what the difference is between a macro and a function. Should we ask on a Twitter? I have a Twitter open. Should we ask? In CS, what is the difference between a macro and a function? Asking for a friend. I am a physicist. Physicist. This, can we see a programming question? Well, let's see if anybody answers this at any point in time. I doubt it happens. Cool. Okay. This code contains a lot of information, so let's go over it. Line by line. Because if we didn't go line by line, then we would be going but like, woohoo. To obtain user input, then print as an output, you need to bring in the I/O input/output library in scope. Well, guess. Obviously, we need to bring that in scope. I feel like the sound on my computer does not quite correlate to the sound of the Twitch stream. And the solution to that is but the volume of... Oh. I know I have to do. I don't know what I did, but I definitely turned off the music on the stream, and that's my fault. And that's exactly what we don't want to do. Okay, yeah, but now it is definitely a whole lot quieter than it was a minute ago. Okay, well, I guess, yeah, it doesn't correlate. Okay. From the standard library, which is known as an STD. Whatever. People do dumb things. So, this is I/O library. Is this a crate? From standard lib. I feel like you have to add library on there, or else we're just putting STDs everywhere. Literal STDs. Like the letters S, T, and D. That's a bad pun. That's a really bad pun. Somebody undo my puns. Stand up straight. Okay. By default, Rust only brings a few types into scope in every program in the prelude. What the heck is a prelude? The Rust prelude. Oh. Rust comes with a variety of things in its standard library. However, if you want to manually import every single thing that you use, it would be very verbose. By importing a lot of things the programmer uses isn't good either. The balance needs to be struck. The prelude is a list of things Rust automatically imports into every Rust programming language. It's kept as small as possible. Oh, I see. Prelude is jargon for minimum amount required to compile. If a type you want isn't used in the prelude, you'll have to bring it into scope explicitly with a use statement. This is literally what we just did. Using the std::io library provides you with a number of useful features, including the ability to accept user input. As you saw in Chapter 1, the main function... Okay, entry point into the program, yeah, we know that. FN syntax declares a new function, and the parentheses indicate there are no parameters, and the curly bracket starts a function. I wonder... So today I was interviewing somebody for my work, and I swear I saw a main function in Java accepting arguments. Which is like, again... weird to me, the thought of a main function accepting arguments, because of Go being my first real programming language. Like, I've programmed in other languages, but I didn't work in them. Like, do real amounts of coding in them. Like, college courses don't count. Like, Go is the first language that I used outside of a programming course, so I consider it my first language. And... not only is that uncommon, it is. 1. 2. like, I don't feel like it's a really good language to compare everything to, because, like, Go stole a lot of things, but it left out more than it borrowed from other languages. Right, Mr. Matt? I love dogs. I love dogs. The FN syntax code and blah blah. You also learned in chapter 1 the print line is a macro that prints a string. That was just Jake getting in the bathroom, Max. You don't need to be startled. This code is printing a prompt stating that name the game is and requesting your input. Storing values and variables. I've done a little bit of this. Using the Rust by example. Rust by example is not quite as hand-holdy. This is definitely very, very hand-holdy. Looks like the 30 frames per second is doing it, y'all. We're doing a great stream at 30 frames per second. That's really unfortunate. Somebody needs to get a better computer. We'll next create a place to store user input. So we'll call that guess. Oh, they already have that. Store the user's, come on, input. Cool. Now the program is getting interesting. There's a lot going on in this little line. Are we going to go word by word now? Why are we going line by line if we're going word by word? Notice that this is a let statement. Very common. In not Go. I know they use it in JavaScript though. Create a variable. Here's another example. Let foo equals bar. This line creates a new variable named foo and binds it to the value of the bar variable. In Rust, variables are immutable by default. We'll be discussing this concept in detail in the variables and mutability section in chapter 3. My goodness, I hope I learn Rust before we get to chapter 3. The following example shows how to use the mut before a variable to make that variable mutable. Let foo equals 5 is immutable. Let mut bar equal 5 is mutable. I did know that. I did know that you have to specifically define a variable as mutable in Rust for it to be mutable. Like a lot of languages have variables mutable by default, and Rust is the exact opposite of that. Probably for memory reasons, like, right? Like, the whole point of Rust is to, like, be, like, as memory conscious as possible. Okay. Let me just say, this grape raspberry, I was very skeptical. And it's great. It's really great. Okay. Let's return to the guessing game program. Oh, we were not there. Oh, yeah. Comments are 2 backslashes. Which is also how you comment in Go. And, like, a ton of other languages. Like, the double backslash is super, super, super common. Sorry, I just got distracted by my own thoughts. I was trying to think about the new mic I want, because I want a new mic that lights up. Come on. Gotta hit 5 subscribers before we can get that new mic. And then we could pay for a music subscription too, that's YouTube safe. Let's return to the guessing game. You know that let mute guess will introduce a mutable variable named guess. Yep, we did know that. The other side of the equal sign, parentheses, this is what an equal sign is the value that guess will be bound to, which is the result calling string : new. The function returns a new instance of string. String is a type provided by their standard library that is growable, UTF-8 encoded bit of text. Any questions there? I can explain what growable UTF-8 encoded bit of text means. There are any questions? Like, this is like extra hand-holding. So basically what that means is they're saying once the string, we don't know how big the string's going to be. So we're going to say that once the string is defined, it will be memory set, right? Because it's, no, it is mutable. I apologize. I forgot it was mutable. So basically what they're saying is we don't know how much memory we're going to allocate to this. So we need to be able to change how much memory we can allocate. UTF-8 is a text encoding, which allows for various characters, including non-Latin characters, including in addition to numerics. And so basically it's just saying that the string is going to be a collection or list of UTF-8 characters, UTF-8 encoded characters that can be translated into human readable text at a future point in time. I hope I did not make that just more complicated. I don't know why I even explained that. Maybe for myself? Did I explain that for myself? This is all for me. I'm on the stream alone by myself, so this is all for me. But hey, streaming every day keeps me committed to professional development, which is honestly good. I need to know more languages than Go, even though I'm a gopher for life. Can we hashtag that? Hashtag gopher for life. Anybody who hashtags that, I'll send you a sticker. Hashtag gopher for life and then tag me and I'll send you some stickers. And then tell me why Go is the best programming language ever. Okay, the ... syntax and the new line indicate that a new is an associated function of the type string. What the heck is an associated function? I'll look and tell me. An associated function is implemented on the type, in this case string, rather than on a particular instance of a string. Some languages call this a static method. Okay. I feel like if I had done more OOP, this would make more sense to me. This is what you get when you're not a computer scientist. Should we Google Wikipedia? Wikipedia. Static. Like, this literally feels like something that you learn in a textbook. Okay, static methods are meant to be relevant to all instances of a class rather to any specific instances. They are similar to static variables in that sense. An example would be a static method to sum the values of all the variables of every instance of a class. Told you it was OOP, which is object-oriented programming. So great. Okay. The new function creates a new empty string. You'll find the new function on many types because it's a common name for a function that makes a new value of some kind. Okay, so how I interpret this, and this could be wrong, but this is my interpretation of it. That new method, or what were they calling it? Associated function, is saying it is what allows us to allocate the memory to the mutable variable after the fact, right? Because it's not defined yet. We don't know what the string's going to be, but we have said that this function will become a human readable value because we have put the associated function in its place, right? Like it's like a pathway or a channel or like a placeholder, I guess, for what will be our variable. If we read on, we'll probably find out that I'm 100% wrong. But you know, whatever. This new function creates a new empty string. You'll find a new function on many types because it's a common name for a function that makes a new value of some kind. Yeah, like it's probably like the self-defining thing. It's totally not in Go, which is why Go's better. It has nothing to do with why I think Go's better, but I will continue to say that Go is amazing. To summarize, the let mute guess equals string : new parentheses semicolon. This is really fun to read it that ridiculously. Line has created a mutable variable that is currently bound to a new empty instance of the string. Phew! Yeah, I feel like that. New empty instance of the string. That's what I meant to say. That new associated function allows us to fill the empty instance of the string. That's it. That's what I meant. I just didn't have the term empty instance until just now. Recall that we included the input-output functionality from the standard library with use std : io semicolon. Because if it doesn't end with a semicolon, it's not ending. That's what allows you to wrap things. Like this. This is really just wrapped. Recall that we included the input okay, yeah, on the first line of the program. Yep, I do remember that. Now let's call the standard in function from the module. So now we are no, that's not what I want. Call in call function to read input from standard in. So standard in and standard out. Why did that format it that way? No, I want it to format it. That's what I wanted. So standard in and standard out are typically like, it would be the environment where it runs. Like if you're doing it in the terminal would be your standard out in, standard out. If you are running it in on a kernel, the kernel would be your standard in or standard out. If you're running it on a VM, then the terminal interface is that VM, and that allows you to like your logs print to your standard in, standard out, like stuff like that. If you're doing it on a web page, then it would be the console of the browser is your standard in, standard out. I have not done enough web development to certify that, but we can pretend like I'm right. So it's gonna read it in, and then when it says read line, I was calling this a pointer previously, but that part is probably saying something like, let's mutate this variable. Or I mean, I guess it probably is, right? It's probably saying point to this variable that we can mutate, right? And the pointer allows us to reallocate that bit of memory, right? Because we need to redefine this. So it probably is some way of defining a pointer to this variable that this function then acts on. And this expect will do something like requires the action to be taken. Like, I don't quite know how it requires that action to be taken, but that's definitely got to be what it does. So, should we read it and make sure? We should definitely read it and make sure. Okay. Read it and make sure. If we hadn't put the use std::io line at the beginning of the program, we would have written this function as std::io: standard in. The stdin, as I've been reading as standard in, function returns an instance of the former. Can I just say the former without being too ambiguous? Which is a type that presents the handle of the standard input of your terminal. That's very, I feel like that's common for imports. That's not how they work in Go, but that is definitely how the use works in Python. You do have to like declare every inherited object when you import. It's like an inheritance thing, right? And you have to declare every layer that it's inherited in order to get to the actual attribute you want to use. In this case, I guess this would be not an object thing, right? But like, I guess, and they're crates, and they have internal crates, but you have to go through each internal layer to get to the actual function you want to use. That is how it works in Python. So this is very, very, very familiar as far as that works. Still kind of vague on the terminology, but terminology is all semantics. It smells like Febreze, the Febreze. Aerosol cans that you spray in the air. My goodness. Okay, we got to get through this chapter so I can go to bed, so I can have an early morning interview and interview people in India. Because in India it is like 8 a.m. It's almost like 12 hour difference, so they should be just getting up, getting ready to. If I was in India right now, I'd be preparing for an interview, essentially. That's where we're at. The next part of the line, the code, .read_line with the &mute guess calls the readLine method on the standard input handle to get the input from the user. We're also passing one argument. readLine : well, yes, this is the mute guess is the argument. The job of the readLine is to take whatever the user types into the standard input, right, and append that into the string without writing over its contents. What? Okay, they're not calling it a pointer, they're calling it a reference. That's good now. That's a reference. I've been waiting for that. Is it an attribute of readLine to append only? I bet it is. I bet it would say write if they wanted it to replace. I 100% bet that that's like an attribute of the read only. Otherwise, it would be a write. The ampersand indicates the argument is a reference, which gives you a way to let multiple parts of your code access one piece of data without needing to copy the data into memory multiple times. This is a pointer in C languages and Go. References are a complex feature, and one of Rust's major advantages is how safe and easy it is to use references. References are ideal for memory safety. Right? Like, you don't, the one thing about using a reference or a pointer is like you're always, like, if you have, I had this was explained really well to me once. Like, I don't have, like, any way to just, like, draw that for you, but essentially, like, if you have this pencil, I don't know why I'm explaining this, you probably all know this. but again, this is for me. Like, and if you were to define a string, like, say, like, this was your memory, and you had this much memory, and it's like, when you define a string, you take up this much memory, right? And when you call it again, you're gonna take up, well, like, if you reassign it or reuse it, you're gonna always take up more memory, and eventually it'll realize this one's not being called anymore, and a garbage collector will come clean it. But when you use a reference, it always points back to that same initial thing, so it doesn't keep reallocating bits of memory to the old thing. That was really bad exclamation. You do not need to know a lot of the details to finish the program. For now, all you need to know is that, like variables, references are mutable by default, hence you need to write at mute guess rather than at guess to make it mutable. Okay, so if I didn't have this, I wouldn't be able to change it. I wouldn't be able to act on it. I would just be able to interpret it, right? So the mute is what allows me to change it. Otherwise, if I just reference guess, it would only be allowed to read it, not write to it. That makes sense. But I won't get to learn about references until chapter 4. Can we not go to chapter 4? Oh my gosh, I just realized it's been an hour and we haven't even gotten through the copy and paste. Oh my goodness, this is gonna take 12,000 years. Oh my goodness! Oh, people are liking my stuff on me. On the Instagram. Don't you love it when people love my stuff on the Instagrams? Which everybody should follow me on Instagram. Instagram's the best. Lulu! Come here, I'll give you scratches, Bill. I know, you want your tummy scratched. She got, shaved today. Took her to the groomer, so she's a little uncomfortable. But we're doing good. We're doing good. She's doing great. We love Lulu. This is taking forever. Okay. Handling potential failure with the result type, which is this. While we're working on this line of code, although we're not discussing the third line of text, it's still part of a single logical line. Yeah, I know it is, because the semicolon. When you call a method with the .foo semicolon syntax, it's often wise to introduce a new line and other white space to help break up long lines. Yeah, probably is. It's more readable that way. That's definitely how they do it in Python. Not so common in Go. I don't know why. I don't know why it's not common to do that in Go, but like, this is definitely a standard way of writing white space in Python. But in Python, like, your white space matters a lot. As mentioned earlier, readline puts the user types into a string we're passing to it, but also returns a value. In this case, an IO : result. Rust has a number of types named result in its standard library, the generic result, as well as specified version of submodules, such as IO result. Results are enumerations, often called enums. An enumeration is a type that can have a fixed set of values. Those values are called enums variants. Chapter 6 will cover more in enum. That's, I guess that makes sense, since it doesn't need to return anything, seeing as we're acting on the reference. That's just weird to me. but I'm sure that's very common in other things. I'm sure it's super common in other things. For result, the variants are OK or error. The OK variant indicates the operation is successful, and inside OK is also successfully generated value. The variant means that the operation failed, and error contains information about how or why the operation failed. Well, yeah. Oh my goodness. For the purpose of the result type is encoded error handling information. Value of the result type, like values of any type, have methods defined on them. The instance of IO result has an accept method that you can call. I'm not clicking on that error. If this instance of IO result is an error value, accept will cause the program to crash and display the message that you pass as an argument to accept. If the readline method returns an error, it would likely be the result of an error coming from underlying operating system. If the instance of IO result is an OK value, accept will take the return value that OK is holding and return just the value that to use so that you can use it. In this case, that value is the number of bytes in what the user entered the standard library. Okay, I'm reading that again because that didn't process. If this is of IO is an OK value, accept will take the return value that OK is holding and return just the value that you can use so you can use it. In this case, the value of bytes entered. Okay, so we really don't care about that. Because we're acting on the guess, and I really don't care how many were entered. I edited, but it's good. Like, I guess the accept is a very standard method of error handling. Not in Go, but in other languages, it's very common to have an accept handle. So, like try accept is in Python, I believe, and I think there's an accept in Java. So accept is pretty common, and they just use the accept for handling their errors, which is whatever. Not as cool as Go, where you do if else error equals return error. Like, that's way better. Not really at all, but it's like it's more lines and more verbose, and people hate it, but I love it because Go's the best. If you don't call accept, the program will compile and you'll get a warning. The program will compile and you'll get the warning. This result may warn unused, must use, on by default. This result may be an error variant. Okay, so because this function readline returns a result, we must have an accept or else it won't compile. That's how I interpret that. Good, we're all in agreement. Printing values from the println macro placeholders. Aside from the closing curly bracket, there's only one more line to discuss the code so far, which is the following: the println exclamation point, you guessed, colon, curly bracket, guess. So the way this works, I know how this works. I might be able to explain it faster than reading through all that code, and then we can just test it. Essentially, how this works is it's defining a string with a placeholder for an argument. That's what the curly braces do. And then you specify the argument that you want passed in, which in this case is guess. Aren't you so proud of me that I know something about Rust? I'm not just making crap up. Sometimes I make crap up, which is also exciting. But we would prefer that I don't make crap up and that I know what I'm talking about, which I do today. You know. Which is super exciting for the moment. Cool. Okay, so testing the first part. Let's test the first part of the guessing game using run cargo. Okay, let's do it. Let's run the function that we generated. Yay! Fake programming. Okay, please input your guess. I'm not gonna put 6 like they put. I'm gonna put 12. I wonder. Oh, I hit enter. That's why there's a space after that last line. Wait. Would there be a space after that last line anyway? So if I just did 12, I have to hit enter or else I won't read it. Interesting. Jake, will you scream like that again? He can't hear you. My nephew's in the next room playing video games. Which is why you hear the random noises, but he likes to have noise-canceling headphones on while he makes random noises. The noise-canceling headphones do not have the game, they have YouTube videos. So, the end. Okay, at this point the first part of the game is done. We're getting in the keyword yay, then printing yay! Yay! Guys, I only have like 15 more minutes before bedtime. Oh, look at that. Range. Oh, this is the random generator. Looks like, so if I were to... What? There's a question mark thing that's supposed to mean something. This means this code does not compile. Oh! Is Ferris the crab mascot? That's pretty awesome. Cool. I just jumped ahead because, like, I mean, I feel pretty confident in what we're doing, and I could probably just, like, not read all of this. Okay, I'm getting bored reading this, essentially, and I feel like I could skim it and get it, but skimming, I don't quite know skimming is the quality content that everyone wants in life. So there's that. But the one thing I do need to read is I do need to read about, not necessarily generating a secret number, because randoms I get, but the crate stuff. I'm not quite clear on how their dependencies work, and like what a crate is. Like, what's a crate versus a library, and like, why do we care about them, and etc. And so, like, that's like a bigger deal. But like, yeah, this might be a better place to end than that. Generating a second number, go through crates, get all the crates, build, updating the version of the crate to get a newer one, generating a random number. Let's go through the crate stuff. We'll end at generating a random number, and then this is where we can pick up tomorrow. You know, going through this thing's taking forever, but we will learn Rust. I will learn it, and I will write things in it. I don't know what I will write in Rust. I will not be learning how to talk to my toaster with Rust. I don't know what I will write in Rust, but we'll figure something out. We'll figure something out. Okay. So remember that a crate is a collection of Rust source code files, yeah? That's probably the best definition of a crate. The projects we have been building is a binary crate, which is an executable. The rand crate is a library crate, which contains code intended to be used in other programs. So crate is a library. Crate is also a program. Like the binary executable, I would just call it like a scripter program. But that's a crate. Everything is a crate. Cargo's use of external crates is where it really shines. Before you write code that uses rand, we need to modify the cargo table file to include the rand crate as a dependency. Open that file now and add the following line beneath the dependency section header of cargo created for you. Be sure to specify rand exactly as we have here for the code examples in this tutorial may not work. Why do I have to add it manually? Why can't it be like super smart? The cargo lock was generated by the build. Okay, cool. And so now I should be able to build it and get all of the dependencies, and that should show up in the lock. And that's okay. The number 803 is actually shorthand for that caret, which means a version that is at least this but below 9.0. Cargo's considered version to have public APIs compatible version with that, and this specification ensures you'll get the latest patch release that will still compile on the code in this chapter. Any version 9.0 or greater is not guaranteed to have the same API as the following example uses. Interesting. So let's import all that fun stuff. Okay. A fun way that I do, like, because the cargo lock is generated from the toml. It's really easy to like just add your stuff. Oh, dang it. Because we don't want to commit any of the target stuff. Sure, Jake? Yeah. Yeah, so everything that's target, we shouldn't compile. But that's only, like, doing that at the top level. So you're gonna get my dog's treat, Jake? Go get a treat, bud. This should take care of it. Yeah, that's not gonna work. See? I have no idea if that's working. CD guessing game? Nothing to commit. So now we can do cargo build and see what was generated. What? What? It didn't tell me I had to add that, did it? See? It told me it would work. Oh. I know why. It is because my SSH is locked. We've had this problem before. What do I have to do? I had to... No... I had to do something. I swear it was a cargo thing. Cargo build, cargo check, cargo run, cargo version, cargo build, cargo search, cargo build, cargo new. It's because I have an SSH lock on my SSH key, and I fixed this in my history. Somewhere around probably 559 months. That's it. Now I can do it. I knew it. See? Worked just fine. It compiles all the things. And then if I run cargo build again, it won't have to compile all the things, because we already did it. See? So now we should be able to, it says right here, it should update it, right? And it should keep it within at least one version. So if I do cargo update, see, it didn't download any. It updates the index. It didn't say it updated it beyond that. So we have almost everything just in cargo lock, nothing in cargo diff, which these are all the dependencies of that. Cool. Why did it say that cargo update would do that? By default, cargo is only looking for vision greater than 8.3 and less than that. If the RAND crate has released 2 new versions, 8.4 and 9, you'll see the following. Oh, if! Didn't happen. Cool. So now we're on generating random numbers. Well, that's awesome. Well, we'll call that a day. We will put a pin in it right here. And this is where we will be back tomorrow. Thanks, guys, for hanging out with me. Having the world's greatest party. You know, just twitching out. We will be back tomorrow at the earlier time. The earlier time being... What time do we stream, Max? We stream at like 2 o'clock Mountain Time? 2 to 5? 2 to 5:30? Something like that. we'll be streaming and chatting and having a good old time. So let's see who's online. Who can we go and hit up? Alt F4 streams pretty cool. Strager's pretty cool. StarCraft is always cool. Coding games. A lot of people make games on this thing. I develop things. It's not online right now. We'll go ahead. We'll stick a raid on Strager. It says yes, Strager. And we will see you guys mañanita. See you guys mañana. What you gonna do?
Here we go again.